My name is Anna Gebruk, and I'm going to be the chair of this session today. So this is the ScAN, Scottish Arctic Network, Research Spotlight session. I know we're a very small group at the moment, but this is the first day of the conference, and we are so grateful that you made it here. I know that a couple of you took the train journey specifically for this meeting, so thank you so much for coming. Just a couple of quick housekeeping things first. So we're not expecting any fire alarms today, so if we hear one, this is a real one. And we will follow the green exit signs just through that door, and the meeting point is outside of this building, just outside of the South Hall. To our participants joining online, welcome. I hope that we have a good group already, and hopefully some more joining through the day. So the way we will run this session today is we will have 3 presentations, and after that we will have a discussion part. So if you have any questions, save them for the discussion part, and then we will invite you to either type your questions in the chat or just raise your hand, and we'll invite you to speak, to unmute yourself and speak. And when we will have a discussion part, if I could also encourage you to turn your camera on so that we could see you, that would be absolutely wonderful. And then the final thing I need to do before we start is just to remind you that ASSW is a collaborative and inclusive space, and we have a code of conduct which is available at the ASSW website, so please have a look at that to get an idea of the expected behaviors and behaviors that will not be tolerated at this event. All right, with that I think we can progress to the actual session today, and the first thing that I wanted to do when I get the slides running, hopefully. Just give me 1 second. Fantastic. Just a very quick introduction to ScAN, the Scottish Arctic Network. So this is a network that's established relatively recently in 2022, but it is a very fast-growing network of the universities in Scotland that have Arctic interests, and particularly the universities that are members of the University of Arctic. So University of Arctic have a stall actually in our exhibitor area in Kirkland. So if you're here in person, please do have a chat with them. I'm sure they'll be delighted to show some of their materials. And Scotland is very proud to have 11 members of University of Arctic at the moment. I think that's the right number, which makes us the second largest non-Arctic membership of the University of Arctic. So clearly there is a lot of relevant research happening, a lot of members that are part of different thematic groups, and this is the point of the session today. What we wanted to do is just give some of our members a little bit of time to talk about their research. So we will have a great lineup of 3 speakers, which will talk a little bit about their research, and as I've mentioned, after that we will have a discussion part. In the meantime, after the session, if you want to learn more about ScAN, we have little flyers just outside, and also the website there is an excellent resource. Okay, with that, I think we will invite our first speaker to the stage. So Beth from University of Glasgow will be talking about the carbon sediments, I think. Fantastic. Thank you, Beth.
Okay, good morning, everyone. Everyone's so spread out, but it's good to see you here, and hello to everyone online. Yes, thanks for the introduction. My name is Beth, and I'm a PhD student at the University of Glasgow. And I'm currently working with my supervisors, Nick Kamenos and Heidi Badat, who are both based at Umeå University over in Sweden, and then Karen Cameron, who's also based at the University of Glasgow. And today I'll just be talking a little bit about my current PhD research, which is looking at Arctic and subarctic marine sediment carbon stocks. So, carbon is the building block of life, and it is constantly on the move around our planet, from the atmosphere to the oceans, to land, and plants and living organisms, and into marine sediments. And it's this carbon in marine sediments that I'm particularly interested in. But why? So marine sediments are a really important component of the global carbon cycle. They are vast sinks of carbon, and they can store carbon for millions of years if they are undisturbed. By removing CO2 from the atmosphere and storing it in the sediments, marine sediments help to regulate climate change, and they could be seen as a nature-based solution to mitigating climate change. However, despite this importance, they are vulnerable to anthropogenic pressures. And as I'm sure many of you are aware, the Arctic is warming nearly 4 times faster than global averages, which is causing catastrophic effects across the environment, including increases in sea surface temperature, declines in sea ice, increased precipitation, and increased river discharge, all of which could affect the production, the delivery, and preservation of carbon in marine sediments. And in addition to these environmental factors, anthropogenic activities such as dredging or trawling can also disturb the sediments and leave this carbon vulnerable to remineralization, potentially increasing carbon emissions in the atmosphere. But despite this critical importance and their vulnerability, carbon in marine sediments across the Arctic and subarctic are yet to be spatially mapped and quantified. And maps of carbon in marine sediments is really important to be able to implement effective conservation and protective measures to ensure that this carbon remains locked up within the sediment. So to address these knowledge gaps, we asked 3 main questions. Firstly, how is organic carbon distributed across Arctic and subarctic marine sediments, and where are the hotspots or high concentrations of carbon? Secondly, how much carbon is stored in the top 1 metre of Arctic and subarctic sediments? And finally, what are the drivers of organic carbon distribution? So what are the factors that are leading to the variation in carbon stocks? So moving on to the methods, we conducted a systematic literature and data search across Pangea, Scopus, and Web of Science, and we looked for marine sediment cores across the Arctic and subarctic from 50 degrees north to 90 degrees north, and then collected the organic carbon concentrations for all these sediment cores. This figure here shows the distribution of sediment cores within the database, which we call the Arctic ZOC database, and this is just overlaid on a bathymetry map. So in total, in this database, we have 1,414 sediment cores. 794 of these have organic carbon data readily available, and a further 620 the data isn't available. So just a plea to all scientists to make sure they share their data after publishing it. The distance between cores is 33 kilometers. That's the mean distance between cores, so pretty good spatial resolution. The highest number of cores was recorded in the Arctic Ocean at 205, followed closely by the Greenland Sea at 203, and then a pretty high number of cores in the Baltic Sea at 142, given its size. More than half of these sediment cores were reported in the continental shelf at 65.8%, followed by the abyss at 22.4%. So using this database, we then went on to conduct forest-based regression in ArcGIS. We used 1,000 decision trees and 21 biotic, environmental, and physical predictor variables that went into the model. I won't read them all out in the interest of time, but they included factors such as temperature, chlorophyll, distance to rivers, distance to glaciers, sediment biomass, and this included both benthic and surface parameters. We then went on to calculate carbon stock, so we went from organic carbon concentration to carbon stock in megagrams per hectare, and to do this we calculated the bulk dry density across the area, created a raster using both our organic carbon data and data from Atwood et al. 2020. And so moving on to the results. This figure here shows the spatially modelled organic carbon concentrations within the top 1 metre of sediment across the Arctic. The range of organic carbon concentrations was from 0.23% through to 5.8%, and the mean was 1.01% across all pixels. Hotspots were identified in the Baltic at 3.34%, the Kattegat at 3.13%, and the Bristol Channel 3.06%. So we've kind of identified the regions where we've got high concentrations of carbon and potentially those regions that are most important to protect. So just a quick look at the model performance. On this figure here, we have measured organic carbon concentration on the x-axis and predicted organic carbon concentration on the y-axis. And when we plot our data, each grey dot being a sediment core that went into the model, we can see that there's good agreement between measured and predicted organic carbon, with most of the dots aligning close to the dashed line, which is the line which represents the one-to-one ratio where measured equals predicted. And we found that the forest-based regression model explained 86.7% of variance. So we worked out that 236.6 petagrams of carbon is stored in the top 1 meter of Arctic and subarctic marine sediments. So this is the big number that I kind of want you to remember. And we found that more than half of this, so 56%, is stored in the shelf, followed by 33% in the abyss. And when we spatially averaged this across the whole of our study site, we found that 84.14 megagrams per hectare of carbon is stored within this area. And when we compare this to global averages of 66.56 megagrams per hectare, it is significantly higher. And this value came from Atwood et al. 2020. So this kind of suggests that Arctic and subarctic marine sediments are really important carbon sinks. They play a large contribution to the global carbon marine sediment stock. So using the World Database on protected areas, we calculated that just 0.09% of this carbon is currently protected, so currently resides within a protected area, which leaves like a significant amount of carbon that is vulnerable to human activities such as dredging or trawling that could remineralize this carbon. So this figure here, down the y-axis we have a list of all of the predictor variables that went into the model and their importance as a percentage on the x-axis. And yeah. So we ran the model 250 times so that we could get a distribution of the importance of each variable. And we found that sediment porosity, sea surface chlorophyll, and sea surface salinity were the most important variables in explaining organic carbon concentrations. And I guess a really important consideration to think about is how these variables might change in the future as the Arctic continues to warm. As we know that with increasing temperatures, there's an increase in ice melt, which is leading to local freshening, affecting salinity levels, and also runoff from glaciers is causing phytoplankton blooms, which could have a significant impact on the carbon in marine sediments. So just some key takeaway points from this presentation. Arctic and subarctic sediments do play a large contribution to global marine sediment carbon stocks, and on average they store 1.3 times more carbon than global estimates. Over half of the carbon stock is stored in the continental shelf, with hotspots in the Baltic, the Kattegat, and the Bristol Channel, which kind of implies that these are key regions that we should potentially think about considering to protect. And thirdly, given that the key predictor variables are likely to change in the future as the Arctic continues to warm, and that just 0.09% of total carbon stock is currently protected, humans will likely play a large role in shaping the future of carbon stocks across the Arctic and subarctic. And that is all I have. Thank you very much.
Fantastic. Thank you so much, Beth. I hope you have some questions, but please let's save them until the later part of the session when we have a panel discussion. And for our next speaker, I'm delighted to invite Georg Kodl from University of St Andrews, who I think will be also talking about soils and sediments, but we're moving from marine to terrestrial zone now, speaking about Tundra. The floor is yours.
Perfect. Thank you, Anna. I just click it through here. Yes. Is there also a time?
I'll tell you when you run out of time.
Okay, perfect. Well then, thank you very much. My name is Georg Kodl, or Georg Kodl in English. I'm just about to finish my PhD at the University of St Andrews, hopefully submitting my PhD in 2 months. So it's a very tense time, and I'd like to present part of my research, which is about microclimates. the Arctic tundra is changing at a rapidly pace, and I devoted myself my PhD to see how we can actually monitor the tundra most efficiently, but also what are the ecological processes happening there. About the monitoring, it's very important to know the scaling biases when we monitor it from space. And also a recent paper I just got published last month where I talk about this and the misinterpretation, for example, that the Arctic greening is not necessarily better and can actually be a result of land degradation. However, today I will talk about microclimates and why they are important in land cover and vegetation distribution in the tundra. So the general concept idea is that topography, small undulations in the landscape, they're creating those microclimates. And these microclimates can exacerbate certain environmental processes, and they, both topography and microclimates, influence the land cover distribution and our vegetation. However, I was interested in understanding like these microclimatic responses are not similar across the tundra. Therefore, I tried to research it in two different distinct areas. One is in northern Iceland, the other one is in northern Finland. And the research study in Finland was also supported by the Saltire Fund from SAGES, which I'm very grateful for and actually really extended the scope of my research. So to the left, you can see the environment in Iceland. It's a very degraded environment. Those bright spots is barren cover. So we have a large amount of barren cover that comes from historical deforestation and high grazing pressure, which led to this strong degradation. Additionally, we have andesals. They're very young soils. They just got created from the last glaciation period. And they are particular in that case that they can retain soil moisture very well, but they're also very prone to soil erosion, so they're not very cohesive, and when the wind comes, then they just get easily blown away. We have, in general, more milder winter conditions due to the Gulf Stream, and also rather typical tundra vegetation. And we are very interested, and we really want to know where soil erosion will occur in the future and how it will change with the global climate changes, these changes. And in Finland, to the right, we see it's a very fragmented landscape, which is also governed by those undulations in the curvature. And we have less soil erosion. We have, in general, higher biodiversity. There's way more plant fragmentation, more plants, more diverse plants. And the cryosols are very different soils to the Icelandic ones. They're very thin. They can't retain soil moisture very well. However, they're not so susceptible to soil erosion. And here we also like to understand how the land cover change will be affected by the changing shifts in the climate. So the general concept of microclimates and environmental stress is that we have the environmental variables. They impact the landscape differently depending on in which positions we are. In the summer season, in the hollows, we have ample soil moisture. We are protected from wind. We have nutrients. But when we go to the rich position, these environmental variables get depleted, and also we have wind exposure. In the winter time, we have a way different picture where snow cover plays a crucial role in governing these microclimatic filters. And here we see when we have a lot of snow cover, there's not much actually stress occurring in different topographic positions due to thermoregulation. Maybe at the ridges we have a bit higher stress factors depending on the thickness of the snow cover. However, when the snow cover is decreasing, the stress at the ridge position is amplified by multiple levels. And that's because we have wind exposure, we have frost activity happening there, large variations in temperature fluctuations. In my study, I focus on the water aspect and the temperature aspect. However, today I will mostly talk about the summer growing conditions. As a metric or for the topography and understanding how the landscape is formed, I use the topographic position index. It's a very simple index that essentially tells us where we have ridges or hollows. That means we take a point in the landscape from a digital elevation model, take the pixels around and see if the pixel in the center is higher or lower. And then if we have positive TPI results, it's a ridge. If it's below 0, it's a hollow. Everything around 0, it's either a slope or a flat surface. So here, I would like to give you an understanding how land cover is actually distributed in the study sites. These data are taken from high-resolution satellite imagery, LiDAR data, and also the Arctic DEM. And to the y-axis, we see it's the fraction of vegetation cover. 100%, we have 100% vegetation cover, and to the bottom, we see the TPI. In Iceland, we see a nice decreasing relationship. That means in hollows, we have fully vegetated cover. The more we go to the ridge position, the more barren areas we have. So there's a clear relationship in Iceland. In Finland, it's a bit different. We see in the hollow positions, we have both low and high vegetation cover values, and that stems from that we have also processes like nivation, where snow gets trapped in hollows, and they maintain the snow cover stays until the growing season. That impacts the biological productivity, and therefore we have a different response than the hollows. However, towards the ridge position, also the vegetation cover is decreasing. So the general idea is that at the ridge position we have low soil moisture due to lateral downflow and wind desiccation. Additionally, we have also soil erosion occurring due to wind distribution, which leads to low organic soils. And then we have accumulation zone in the hollows where we have ample soil moisture, organic soils with nutrients, and that's good for the vegetation. So the idea is, okay, we know that the land cover, barren cover is increasing and difference in the TPI, but how is the vegetation actually responding to it? To do that, went out and did a drone survey, which helps me to classify the landscape and see what is the spatial distribution of the land cover. And also I can assess the land cover through vegetation indices and say, oh, is it doing better in this position or not? Additionally, plant trait measurements were taken from shrub leaf samples and also the shrub height to have some idea of the morphology, how the plants are responding. And then also soil moisture was measured throughout the year, throughout the growing and winter season, each hour. So that gives us a very high temporal resolution, but also a very high spatial resolution, combining these data sets. So these are the study areas. To the left in Iceland, to the right in Finland. I have here two different scales where I look at the vegetation composition in the red area, and then the smaller areas is where I had a more detailed investigation where I deployed soil probes, soil moisture and temperature probes, and also took plant trait measurements. So how is the land cover distribution? In Iceland, here on the top you have a land cover map, to the bottom a TPI map, and we can essentially see, yes, there's a TPI topography is controlling a land cover distribution. We can see that the barren cover is increasing, especially towards the last bits of the TPI, where we have a strong increase in barren cover and a decrease in the dwarf birch, the shrub. In Finland, again, we have above a land cover map and below the TPI map. I could classify here way more land cover types because the landscape is more heterogeneous and more patchy, which was easier to classify from the drone. And it's also here a bit more complex picture than in Iceland. But we essentially can see that also the dwarf birch doesn't like really hollows, and it's also decreasing towards the ridge position. And we have crowberry starts to occur at the higher TPI, barren cover is increasing biocrust. It all indicates that we have actually higher stress levels at these ridge positions, and therefore we have this landscape structuring. Okay, so we see the landscape, the vegetation composition is changing throughout the mesotopography, but how is actually the vegetation doing? So actually the vegetation class Betulanana, that's the dwarf birch, I'm particularly interested in because it's spreading across the whole Arctic tundra most widely. And I took here the vegetation index NDVI that gives, it's an index on the biological productivity. It's also correlated to the leaf area index and biomass. And we can see in Iceland, the shrub is doing the same basically between hollow and ridges. We have the same NDVI across all these topographic positions. However, in Finland, we see the NDVI is increasing towards the ridge position, which is, I find surprising because we know actually that the ridge is a more stressful environment and the NDVI is increasing, which reflects maybe higher biomass productivity. But to actually have an understanding, okay, the NDVI is increasing, but what does it actually mean? We have took those plant trait samples, and we see here on the top is the shrub height. This is the transect in Finland. And we see that the shrub height is actually decreasing from the hollow towards the ridge position, whereas the leaf area is increasing as the leaf weight. So this actually aligns well with the NDVI results from the drone and shows actually the shrub is not stressed, but it's actually adapting. So it's getting, the height gets reduced probably due to higher wind conditions, but also the leaf area is increasing, and that's a likely process of adaptation of the shrub plant to these environmental conditions. Let's have a quick look on the soil moisture conditions during the summer. On the upper panels, these are 1 month snippets. We see that there's a large difference between the volumetric water content in Iceland between those topographic positions. In Finland, we don't see much difference, and this is due to the soils. They can't really retain soil moisture well compared to Iceland. If we have a look at the winter conditions, at the temperature, it's a very different picture. In Iceland, there is not much difference between the hollow blue one and the ridge probe, but we see that during the winter time we have over 2-3 months freeze and thaw activity in the ridge positions. And due to the undersoils, which can retain a lot of soil moisture, that makes them very geomorphologically active compared to areas in the hollows where there's snow cover and there's no difference in the temperature. In Finland, we see a high temperature difference that also stems again from snow cover in the hollows where we have thermoregulation, and we have a high temperature variability at the ridge position, which shows actually, oh yeah, that is a very stressed environment, and shows actually these microclimatic conditions are very different between Iceland and Finland, and also how moisture and temperature is responding there. So to wrap up, what are the key messages? So the study, it has implications how we actually monitor the Arctic tundra long-term and also on a large scale, because it's a very, very challenging environment due to the fragmented nature of the landscape, and therefore the current environmental models we have and also the spatial resolutions in satellite imagery are not sufficient to actually resolve those fine-scale dynamics. And mesotopography is controlling microclimates, and there's a large variability of the landscape. So we have a heterogeneous response to these global changes. And we have to understand it better, how these microclimates actually control these factors. And there are potential consequences, what that actually mean, biogeomorphological consequences from ecological side, but also on the geomorphological side. One means that we have a shift in vegetation types and alterations in the plant physiology. It also means that there are certain ecological transitions that can happen due to variable environmental thresholds that can occur in hollow positions and in rich positions. And it also means that there are changes in soil erosion dynamics, which are yet not clear, but that can indicate that in Iceland, for example, due to reduced snow cover, we have way more increased soil erosion activity due to the winter blizzards and so on, which are not protecting the very susceptible soils. And that's that. I leave you with a picture from the Arctic Research Station in Kilpisjärvi in Finland, and these are also my collaborators I'm working with on these questions. Thank you.
Thank you so much, George. Fantastic talk. I'm sure we'll have questions for you later during the discussion part. So, rather unbelievably, but we are already on the last talk, and our next speaker today is Alona Roitershtein from Robert Gordon University. And Alona will be talking about tourism in Orkney, I believe. And I just wanted to hold the stage for 1 second to mention that, Alona will be talking about tourism in Orkney, and one of the fundaments of the establishment of the Scottish Arctic Network was to see similarities between Scotland and Arctic. So a lot of our members are doing research in the Arctic sites, as we've seen in the other talks, but a lot of our members are also working on the environments and the society, seeing the similarities between the Scottish societies and landscapes with the Arctic. And that's why I wanted to make a quick reference to the Arctic Connections policy framework that exists in Scotland, was launched by the Scottish government, particularly the Northern Europe and Arctic team, and we have some members in the room today. And this network, this policy framework was really quite fundamental for the establishment of ScAN, so we are promoting it. But yes, with that, I am very delighted to invite our final speaker on the stage, and the floor is yours. Sorry, this is the wrong direction. Okay.
Thank you. Thanks, Anna. So my name is Alona, and I am from Robert Gordon University School of Creative and Cultural Business, and I am going to tell you a little bit on a PhD, about my PhD that I'm currently finishing. My viva is next week, so I'm finishing this study about place-based sustainable tourism strategy evaluation in the Orkney Islands. Now, this is my background is social sciences, so it's a bit different from the two presentations that we've seen before. So yeah, my study, the aim of the study was kind of twofold. First, I wanted to propose a method for understanding the local contextual circumstances and their effect on the sustainability needs by Orkney, by the members of Orkney communities. And this is because sustainability transition, and especially when it comes in tourism, is very context dependent. And because it is context dependent, the existing frameworks for sustainability implementation, especially in tourism, are the generic ones, are not exactly applicable to small local destinations. So I wanted to see how can I study this context, and how this what I've understood, what I've learned, how can it be applied to evaluating sustainable tourism strategy in Orkney. And this is kind of the second part of the aim. I want to propose a place-based strategy evaluation framework based on Orkney Islands case study that it can be used elsewhere in the world as well. So Orkney Islands is an archipelago of 70 islands just off the north coast of Scotland. And it's a rural destination But it's not just rural destination, it's also like island destination. It's not just island, it's also archipelago. It's not just archipelago, but it's also cold water rural archipelago. And because this kind of contextual complexity, I decided to kind of create a model that's called layers of context. So imagine that every one of these layers just kind of layered one on top of another, and if you can see through these layers of context on the destination. And there will be some common features of all rural destinations in the world, of all island destinations in the world, and so on. But I also argue that there is this kind of unique contextual circumstances that were pertinent to that particular destination, regardless of its base layers. And this is where this kind of unique layer of Orkney Islands comes in. So this is the contextual circumstances. So my empirical study, so the base layers I studied through more kind of desk-based research and current literature. My empirical study concentrated on finding out that unique layer of context of Orkney Island. So how I did that? By structuring my study as a single case study, a multi-method qualitative case study, which is unusual because a lot of case studies are kind of mixed methods or quantitative methods as well. I look through at the world and at this study through pragmatism and also interpretivism, which is also a kind of an addition of blending two epistemologies on how we look at things. So first I went and did unstructured observations. So I went to Orkney, I spent some time there. I took some pictures and I tried to understand, so I'm not from Orkney myself, I live in Aberdeen, so I wanted kind of to try to understand, create my own understanding on how things work. And then I did semi-structured interviews with members of Orkney communities. And I try to cover all kind of groups of Orkney communities. So there's a big kind of native Orcadian community there. There's a big community of incomers. There's farmers. There is people who are involved in tourism, people who are not involved in tourism, people who live on the main island of Orkney, called the mainland, or people who live out with the mainland, so on other islands as well. So I try to cover as many kind of groups as possible. And after the interviews, kind of towards the end of the interviews, so I did that, it was COVID, so I did that most of the interviews online. I went back to Orkney again. I spent some time there again in order to collect more, kind of observe more things that I already learned from the interviews, to kind of collect illustrations for things that people told me about. And this is where this kind of digital ethnography comes in, because it's not really an ethnographic study, but a lot of ethnographic motifs can be seen through this study. And I used the digital ethnography method to create my field notes. So I didn't write field notes as one would do in the kind of normal observations. I took pictures, and then when I came home from the observation strips, I wrote it up into the field notes. So I've gathered these field notes. I had my transcripts all together. I went on to NVivo, which is qualitative, which is a kind of a software for qualitative analysis, and I did inductive thematic analysis. So what did I learn from the data? So it was driven by the data. From what I've learned from this analysis, I can then formulate this framework that I wanted to study to create in my aim. That framework then I applied deductively already to the document analysis, which is one single document, Orkney Islands, Orkney Tourism Strategy 2030. So this is the methodology. The key findings were, which was a bit unexpected for me because I started my PhD as a more kind of management discipline, more kind of business side of things. I wanted to evaluate a strategy, but because I applied this inductive kind of thematic analysis, I discovered new things. I discovered things that I didn't think about before. And I kind of looked, and that brought me to look at tourism development as a placemaking activity. And place theory kind of became the main theory that guided the rest of my study. I discovered from the conversations, from the illustrations, that from the observations that I did, that perceived value of tourism by Orkney communities, by the members of Orkney communities, and by value I mean not just economic, but also social, environmental, and cultural, is basically a proportionality between perceived benefits and perceived impacts. And the word perceive here is important because it's very individual. Remember, I'm in inductive, interpretive epistemology here. It is very individual. It's very subjective to people how they understand the benefits of a development. In this case, it's tourism, but can be applied to any other thing. And how do they perceive their impacts? So I found that perception of benefits very much dependent on what they know about these benefits. So how transparent the distribution of benefits is in the community. So for example, Orkney is a prominent port for cruise calls. Cruise ships, cruise operators pay harbour dues to Orkney harbours. And Orkney Harbours is a division or kind of business unit of Orkney Islands Council. This is the main money that goes in from that is being the main revenue from cruise tourism. But many people who I spoke with don't know what happens to that money. Where does the money go? Why one? I had a quote that someone said, "Why one cruise ship doesn't equal one play park, for example, or a fixed road, fixed boat holes, or things like that." So people don't know where the financial benefits go. But also there was a lot of centralization in terms of how, so the benefits come into Orkney mainland, but what happens with other islands. So there was a lot of misunderstanding or not understanding what happens to the benefits. Impacts, on the other hand, or kind of in conjunction, were driven by the alignment of the sense of place. And I didn't add, I had, my sense of place is kind of on the people-place continuum. I didn't really add this to the presentation because it can be another completely different presentation. Alignment to the sense of place, how people view their place, what meaning they give to their place, to Orkney. And that varied between different parts of the communities, between the native Orcadians, for example, and incomers. There was different attributes of the sense of place from how I interpreted the conversations with them. So basically the higher perceived value means the placemaking is deemed more sustainable, and higher value means that that particular development will be aligned to the sense of place, and the benefits from it will be transparently distributed or transparently communicated. And therefore that ultimate sustainability need that the strategy needs to cover or needs to address is this increase of the value of tourism in the eyes of Orkney communities. And the value, again, it's not just economic, it's social, environmental, and cultural as well. So this is the framework. It's a bit big. So I'll talk you through it quickly. So here you can see the attributes of sense of place. So this is the first stage. How I evaluated these Orkney layers of context that I showed you in the first slide. So here are the attributes of sense of place, and these are the attributes of the equitable and transparent benefits distribution. If I can recognize how the strategy addresses these, I can provide recommendations into how increase the perceived benefits, decrease the perceived impacts, and therefore increase the perceived value. So this is the strategy evaluation. You notice here that there's a circle that's called power. Power, I found, is like a binding concept between benefits and impacts, because the stakeholders with more power will be the ones whose value is represented more likely in the strategy documents, in policies, and all things that actually create some change. And therefore, the sustainability transition will be driven by those with power. And that is very prominent, especially in rural communities and in island communities, and more so in archipelago communities, where power is centered within the main island of the archipelago, in addition to kind of power centered later on, in our case, in Holyrood and so on to Westminster as well, because there's kind of multiple peripherality. There's a concept about this. So to evaluate the strategy, therefore, I asked 3 questions. Does the strategy address the need for equitable and transparent benefits distribution? And this is how I can recognize that. Does the strategy address the need for the alignment of the strategic direction to the sense of place? And this is how I'm going to recognize that in Orkney context. And whose value the chosen strategic direction represents, and this is the element of power. So this is the strategy, just a snapshot, kind of screenshot of the vision and objectives. You can see the vision is quite ambitious. By 2030, Orkney will be a world-class sustainable destination enriching the lives of its people and visitors. So it's quite aligned with this need, the need for sustainability transition is understood. There are objectives here, but I analyzed the whole document. So it's a 20-page document, including the pictures, and I analyzed it kind of wind and vivo within this kind of deductive framework according to these questions from the framework that I showed you just now. So here are kind of the main takeaways in terms of kind of more recommendations for improvement. There were quite a bit of good things happening there, but the strategy was clearly reflecting the values of those who benefit from growth of tourism. It was very clear, it was very obvious, although there were mentions of kind of impacts or kind of more prominent complaints from the community, but still the strategy was addressing the needs of those who benefit from growth. It prioritized the needs of visitors and tourism businesses according to that growth mindset. And Orkney as an archipelago context was not sufficiently reflected, so it was very centralized strategy. Not just its text, but even its pictures. From the, 20 pictures that were there, only one was identified as from non-mainland, not the kind of main Orkney Island, and 4 were kind of hard to tell where they're from, but that's kind of shows how centralized the document itself is. It was also quite clear that there was some sort of status quo by the local government. So local government or Orkney Island Council is kind of the main power holder in Orkney, and this is the case that the public sector holds a lot of power in kind of rural and island areas, so it's not unique to Orkney. But there was some kind of sense of status quo also from the strategy. It was seen from the strategy. It was seen from previous strategies as well. So similar objectives of this strategy were found in the strategy like 20 years ago. And it was discussed in literature. So not much, the tourism grew exponentially. The tourism now, it's nowhere near what it was 20 years ago, but the objectives were the same. And there's no sufficient evidence of wider stakeholder consultation. So who actually was consulted in this strategy? Who contributed to its objectives? What's the reason for these objectives? Who asked for them? So this is something they can improve on. So back to the same model, but the same framework, but you can see here, this is how it can be applied beyond Orkney. Instead of writing down the actual attributes of sense of place, because they will be different from place to place, the users of the framework can write them down basically here in this bit of the framework. Same with the benefits distribution, because it will be very context dependent, and every destination will have their own kind of policies and their own processes for how the benefits are distributed across its communities. The numbers that you see around here are because this framework comes with another 2 pages, just didn't include them in the presentation, and every page, every number explains what destinations can actually do, what the users of the framework can actually do in order to implement it in their place. For Orkney, obviously, the study provided kind of the opportunity or recommendations for revision of the current strategy and the action plan, and also guidance for future strategy development. However, for other destinations, this framework can be used as well. And if we're looking north, as Anna said, Orkney Islands obviously is not in the Arctic, but we can connect we can connect this case study and apply the methodology, at least the method, the framework, to other destinations. And it is important in the Arctic context. It is important in the Nordic context as well, because there will be a lot of cold water archipelagos around that will be facing similar challenges. Here you have some cruise tourism that is very prominent. It just grows and grows, especially in places like Greenland. I did a little comparison study between strategies of Orkney and Faroe Islands last year, and I looked into how communities perceive their tourism, the value of their tourism in Faroe Islands. There were quite interesting discoveries there. So this is from their media from a few years ago about a cruise ship that was docked in Tórshavn, and the number of cruise ships in Faroe Islands, despite that it's a big archipelago and more population, is nowhere near the number of cruise ships in Orkney. So it's like if they have got 50, Orkney's got 250, maybe not that, but just over 200. This is a picture that I took in Reykjavik last year. Evicted tourists, not the migrants. There's this kind of already a bit of an antagonism, or already this perceived value of tourism is a bit problematic in many communities in the north. And there are strategies in the north that can be reviewed using this framework, such as HAME, but by Faroe Islands, you have here Visit Greenland strategy, and also strategies of Iceland and other destinations as well. And also, I should say, the framework itself doesn't have to be applied to tourism. It can be applied to other sectors as well, where the opinion of the communities should be sought, maybe like transport development or schools placement or any other placemaking activity. And yes, that's me. Thank you very much.
All right, thank you sorry, I'm so bad at not using the microphones. Thank you so much, Alona, that was wonderful. So I would like to invite all three of our speakers to take a seat at the table, and we will have about 15 minutes of discussion, but if we have a lot of questions, we can take even longer if needed. And yeah, for our guests online, if you have any questions, please feel free to type them in the chat or raise your hand and unmute yourself. And having a quick look online, I can see a special guest. I could see that the chair of the ScAN network, Daria, is joining us online. So I was wondering, Daria, sorry for putting you on the spot, but whether you would like to say hi, maybe introduce yourself. We'll bring you up on the screen in a second. I'm hoping the technician team will make the magic happen, and we'll see a Zoom gallery in a second. Oh, fantastic. So we can see you on the train.
Sorry, I'm not there in person. I have heard most of the presentations, and thank you all so much for organizing and for Anna for chairing. I don't have any substantive questions, but I just wanted to thank everyone, and I will see you all in about an hour for the opening ceremony.
Fantastic. Thank you, Daria. I hope you get here safely, and we'll see you later for the other meetings. All right, let's start with the questions. So we had a fantastic lineup with 3 completely different domains: marine, terrestrial, and social. So hopefully we have lots of questions in the audience for all these different topics. I'll start maybe first going back to the first speaker, to Beth. Yeah, so organic carbon in marine sediments. I had 2 questions. The first is really simple. So how do you actually measure it? And is it like a very simple standard procedure, or is there some variability? I was just quite curious to see in the numbers that you reported that there is a lot of cores that didn't have this data. So do you think it's because people are not measuring it, or they're just not reporting it, not sharing it?
There are different methods to measure it. The very standard is mass spec, but there's also loss on ignition and a few different other methods. For my study, I just stuck with mass spec data. And yeah, so those cores that didn't have the organic carbon data, that they have had organic carbon measured in their sediment cores, but it's just that the raw data wasn't presented in the paper. And then when I got in touch with the authors, they didn't have the data to send me. So. yeah.
I guess that's a common problem across different studies, that people are not sharing their data in their repositories. So that's why we have an Arctic Observing Summit, where we are trying to promote those ideas of how to improve that, particularly in the Arctic context. I had another question for you, if that's okay. So yeah, I was also very curious to see the map where you were trying to sort of identify the hotspots and the areas, give an estimate of the organic carbon percentage. So I wonder, how accurate do you think the model actually is? Because you were giving some numbers saying that the hotspots are potentially on the continental shelf, but obviously we have quite a lack of data in the Central Arctic Ocean. So is the model kind of accounting for that, or do you think, maybe there are other hotspots that we just don't know about?
Yeah, it's a very good point. I guess with all models, there's going to be some kind of like error. So I had 623 sediment cores that went into the model, and they were spaced all across the Arctic and subarctic. And then there's a plot that I showed that had the measured versus predicted organic carbon. And for the data that we have, we showed that the model was predicting it pretty close to what was measured. So we're hopeful that that's a pretty good model.
Yeah.
But yeah, I guess the more data that we have that goes into the model, the better it will be. And yeah, there could be like smaller hotspots that we are missing. So that's definitely, something to consider.
Final question for me. Sorry for bombarding you. I was just very curious about your talk. So those values that you're getting, the hotspot, the concentration, is this a static value, or does this change over time? Like the hotspots, do you think there will be other areas that tend to accumulate or release more or less organic carbon? Is it like a snapshot in time? Or account for?
Yeah, that's a really good question. So the data that I presented was the average of the top 1 meter of sediment. And obviously sediments are accumulating over time, so that is going to change. We decided to do 1 meter, as this is kind of like, it's a standard that the IPCC protocols recommend, and allows us to compare against other regions. But yeah, for example, 1 meter depth in deep water, the age of that sediment is going to be very different to the continental shelf. So you have got sort of the rate of organic carbon accumulation that's going to be very different between areas. And that's actually something that we've been looking at now. So we've got some age models for a select number of those cores. And we want to also look at the rate of organic carbon accumulation, because I think adding in this temporal aspect to this study is really quite important as well.
Thank you, super interesting. Do we have any questions in the audience? We have our wonderful volunteer with the microphone, so if you have any questions, please just raise your hand. But in the meantime, go ahead.
Thank you very much. Okay, thank you. Oh, there we go. Thank you very much. A really interesting presentation. To your last point there about temporal aspects, I'm also wondering, will you be taking into account processes of sediment redistribution in a variety of these areas? So for example, I think your map showed that the Beaufort Sea Delta, for example, was quite low. But that also is a very shallow area where the entire sediment is reworked every year extensively within that top meter, if not further down. Same with the Atlantic coast of Canada, for example, with icebergs as they drag through sediments. So those processes would in turn influence the results that people are collecting in their data. So will your model, or will you be hypothesizing about some of those impacts for those regional differences? Thank you.
That's a very good question, and something I've not thought about before, but yeah, definitely something that would be great to incorporate that into the model. I'm not too sure how feasible that would be. Yeah, I guess we need information of like the depth of reworking for different sediments, and potentially whether this carbon is then going to be like remains within that top 1 meter, or if the reworking of sediment is then releasing that carbon. And I guess importantly, if it is releasing that carbon, is the carbon labile or refractory? Like, is it fairly static carbon, or is it carbon that is going to be broken down by microbes and released back into the atmosphere? Yeah, very good question, and I will definitely be looking into that. Thank you.
Here's an idea of a postdoc for you.
Exactly.
Okay, so I maybe have a quick question for Alona. Sorry, I know very little about the methods of social research, and I was just wondering, so you did a couple of interviews as a part of data collection. How did you find it working in Orkney? Were people open for collaboration, willing to participate in interviews?
Yeah, so it was more than a couple. It was over 30 interviews. And yes, absolutely, people were willing to collaborate and speak about Orkney. And this is where the sense of place became kind of my theme, because I felt very strongly that the sense of place was very, very strong. It manifested in different attributes, but as a strength of it, as a willingness to participate and a willingness to make this change towards more sustainable future in tourism and beyond was very prominent. So yeah, and also the fact that I did my observations beforehand helped to build this rapport with participants, because I knew more or less what they were talking about. If they were saying specific location or specific event, I knew about it, and that they would probably feel like, okay, so she knows what she's talking about. So it helped to build that rapport.
Yeah, super interesting. Very good to hear that you got a lot of engagement. And then switching to broader context, obviously you talked at the end that this evaluation framework could be applied to other places as well. So I was just curious if that's something that you want to pursue. Are there any other areas that you would personally want to do as a next study?
Yes, absolutely. I would love to pursue that. I would love to test it in other archipelago contexts. So I would love to do that, say, in Faroe Islands or in Svalbard. I would love also to check that in different contexts, maybe not an island destination, but a coastal destination or a continental destination. Yeah, so absolutely. And I think it's important to test it and important to develop that, and that will help, I think, going forward.
Fantastic. Well, good luck. I hope you get a chance to apply to
Thank you.
as well. Any questions from the audience to Alona or anybody else? Yeah, go ahead.
Thank you all three for your presentation. Particular compliments for the visuals. They were very visual. I'm a PhD student at Durham University. I'm doing political geography. So I'm sorry if my question will be quite simple. And well, since we have this same object of study, which is the Arctic, I've noted that you all included subarctic context. So maybe my question can be you each define the Arctic and the subarctic. I'd be very interested to see that both from physical science and more social sciences.
All right, let's see how marine, terrestrial, and social specialists define the Arctic and the subarctic. Anyone wants to go first?
I can try. It's hard to draw a boundary because, Arctic, there's geographically speaking, geologically speaking, climatologically speaking, sociologically speaking, some parts even Scotland are regarded as subarctic, but from a geographical point of view, it's not. It's rather around the Arctic Circle. However, it really depends on the context what we are talking about, and the line is probably also changing because the climate is changing and there's a lot of variability. So yeah, let's say subarctic will be probably everything which is in Europe, and Arctic maybe the tips of Norway and maybe Greenland. But Europe is definitely subarctic, and then yeah, where you draw in Russia the boundary, I can't tell you, but this is my field in Europe. It's my take.
I think I 100% agree, it's context dependent, and I don't think it's very important to draw that line. I think it depends on what is it you're looking at. So in my case, I'm looking at a specific industry-specific sector, tourism, in a specific context, and the context, as I mentioned, is quite important. And if that context applies to a destination within the Arctic or just out with the Arctic Circle, it doesn't matter where that border comes through, as long as the study or the research can apply or can help communities that live there, regardless if they're within the geographical border or not.
Yeah, I'll just add that I completely agree with what's been said. I guess for my work, I kind of use the Arctic Circle as the boundary. But I guess that's the reason why I included the subarctic in the model, and also because I think because this boundary is potentially going to change in the future, the subarctic might act as a bit of a case study for what's going to be happening in the Arctic. So I kind of wanted to include that in my study. Yeah.
Thank you for the excellent questions, and thank you for the excellent answer. I'm sure there will be a lot of different takes and discussions through the next 9 days of what the Arctic is, where the boundary is it flexible, how we define it. All right, I think we're coming towards the end of our time. I maybe just throw one more question at George. So, yeah, I was quite curious about the environmental stressors and the gradient that you were using there from hollow to ridge environments and different microclimates. And you showed that the two studies that you were looking at, Iceland and Finland, are quite different. But is this gradient and stressors could be kind of same question, could it be applied outside of the Arctic context? Like, for example, in Scotland, would it be, you know, a similar story, or would it be completely different stressors and conditions?
I would say it could be, well, hard to say, because the soils are, again, very different. The winter climate is very different. We have way more sunlight in Scotland. However, there will be I think the methodologies I use it should be also applied to other study sites, because the responses are very different, and actually something also I didn't expect in Finland, for example, that the shrub is doing great. Actually, it's adapting well, and I thought it's actually there will be more stress occurring, and this stress we didn't see in Iceland, but we have way more geomorphological stress, which comes through soil erosion. So it really depends on the climate, on the soils, on the land management, and so on. And I think there can be drawn some parallels to Scotland, absolutely. It's also a degraded land through deforestation, high grazing pressure. So, I mean, these issues are similar across the high latitudes. So, yeah, some similarities, but probably also differences.
Understand your context. Okay, well, wonderful. Thank you so much, everybody. Unless we have any more burning questions in the audience, we will probably be drawing this session to close, but our speakers will be around, and I would also like to invite you to the stall of Scottish Arctic Network at Dynamic Earth on the 26th as a part of the Science Day. You can study the leaflets and talk to different members there as well. So yeah, thank you so much for our speakers for your time today and the excellent talks, and good luck with your vivas and publications.
Thank you.
And with that, we will close the session. Thank you.